Let me share my screen. And in answer to that question, homework 2.1 is due today. Homework 2.3 will be due on Monday. Homework 2.1 is the one that dealt with functions. Homework 2.3 is the one that deals with linear equations. And homework 2.4 is the one that deals with more on slope. There is a quiz. Everybody please notice there is a quiz that is due on Sunday. The quiz Sunday is, I think the name of it is a linear function quiz. But really it's got 5 questions. I'll just say 4 questions, might be 4 questions. Most of the questions, they give you 2 points. They ask you to find the slope through the 2 points and then use the slope to describe the line, whether it's increasing, decreasing, horizontal or vertical. And then there's one question where you're given a point and a slope, and you're asked to find the equation of the line using the point slope formula. Does everybody feel comfortable with that slope formula and that point slope formula? Make sure you do that quiz. If I made that quiz bold and bright and obnoxious enough to make sure that everybody remembers to do it. Make sure you put your work in Blackboard. Then before we pick up from where we left off, note-wise, does anybody have any questions on any homework questions? Does anybody want me to open up anything? Open it up, any of the homework problems, and look at them.
Can you do number 22 from the homework that's due today?
Sure.
It's mostly the domain and range I'm struggling with. Like, I don't know
From
which
the
one
graph?
to, like, I don't know which one to like first.
Okay, give me a second and let me find that question, 22. In order to find the domain and range, and we looked at a few of these last class, the domain is the X values. And so as I look at this blue graph, I'm trying to decide what are the X values for all the points. And so do you notice there are no holes in the graph? So it's going to be all the values in between whatever is the furthest to the left and whatever is the furthest to the right. Does that make sense?
Yeah.
Now, because there's an arrowhead there, it just keeps on going. So there is no smallest X value. It just keeps going further and further and further to the left. So it goes from negative infinity. And as I look at the other side, because of those arrowheads, it also keeps on going. So it's from negative infinity to infinity. Instead, if I want the range are the Y values. And the Y values, if I were to compare this to the vertical axis, it's asking how low does it go? Well, it looks like there is a smallest value, doesn't it? It looks like for the range, the lowest it goes is 1. And there's not a hole there, so we're going to say it includes 1. But as I look at those arrowheads, do you see how there isn't a highest value? It never stops going up. So that ranges from 1 to infinity. Is that the part you were wondering about, hon?
Yeah, a lot of the times I do get the right answer, but I put them in the like wrong way. Like, instead of putting this, I put like infinity first and then 1 second, and it like marks it wrong.
Okay, yes, order matters.
Do
When
I put like
the arrow notation,
Okay.
First number has to be the smallest value. The second number has to be the largest value. Okay, the smaller number has to be first. So I'm always asking myself, what's the smallest X value? What's the furthest to the left? What's the furthest to the right? I'm always at, but the left is first. When I'm looking at the range, I'm asking what's the lowest. The lowest goes first, the highest goes second. They have to be in order. Okay, did you want to try another one?
No, it's good. Like the rest of it is.
Okay, no, I mean, did you want to try another domain range from the next problem?
No, I'm good now. I do have another question though.
Sure enough. What question?
Can you do 28?
Sure.
28?
Maybe. Is that letting me open it? Oh dear. Let's see, maybe if I shrink it down. Yeah. If I have something stretched big. Oh, I love this question. It says, let F and G be defined by the table to the right. Find the following. And so it asks for the square root of F of 0 minus F of 1 minus, and then in parentheses, G of 3 squared plus F of -1 divided by G of 3 times G of 0. What the hell is that all about? Well, let's see if we can use that table to find things. If I use that table, what's F of 0? Well, F of 0, when X is 0, F is 0. So F of 0 is 0. What would F of 1 be? Well, when X is 1, do you see how F is -4? We also need G of 3, right? That's the next thing we're looking for, G of 3. Well, when X is 3, do you see how G is -3? Are you okay with where I'm getting these numbers off the table? Or am I just talking too fast at you?
Yeah, that's where I was confused. Like I wasn't sure like where the number was coming for, you know?
Are you okay? The number in parentheses is the X value.
Oh, okay.
And then you have to go right to the right function. So the next one asks for F of -1. And so as I look at this, when X is -1, you see when X is -1, F is 3. We got G of 3 already. I think we also need G of 0. What's G of 0? When X is 0, what number is in the G column?
9.
9. And so do you see how I use the table of values to find all of those? And so now I'm going to take the square root of F of 0 is 0 minus F of 1 is -4 minus G of 3 is -3 squared plus, oh Lord, I'm writing too big. F of -1 is 3 divided by G of 3 is -3 times G of 0 is 9. And you see how I'm just plugging those numbers in once I figure them out?
Yeah.
And then use your order of operations to simplify. Easier than you thought?
Yeah. Thank you.
You're welcome. Anybody else have any other homework questions?
Is this what gonna be on the quiz, like from this homework?
What's going to be on the quiz are going to be 3 questions that I have to apologize. I don't remember if it's 3 or 4. 3 or 4 questions that ask you to find the slope between 2 points. So there are questions like this: find the slope of the line passing through the pair of points, or state that the slope is undefined if the line through the point rises, falls, is horizontal or vertical. And so with these questions, we're going to find the slope. Remember, the slope is the difference in the y values over the difference in the x values. And so my y values would be 5 minus 1. My x values would be 6 minus -3. And so that would give me a slope of 4/9. Now, because it's positive, it means that it's increasing or it rises. Instead, if it were negative, it would fall. If the slope is 0, it's horizontal. If the slope is undefined, it's vertical. Now, we've been looking a lot at using that slope formula. Most of the quiz is on that using the slope formula. I think there are 3 or 4 questions like that. And then after those 3 or 4 questions, there is 1 question like what we did next. Hey, could everybody who's not talking, please mute yourselves? Thank you. Here, where you're asked to find the point slope form of a line, and then put it in slope intercept form. And so these, remember, we had said point slope was y minus the y value is equal to m times x minus the x value. And so here it would be y minus the y value of the point is 3 is equal to my slope 7 times x minus, well, minus 2 would make it +2. And so the point slope form is that answer. Stop there. And then for the slope intercept form, we're going to take that and simplify it. Y minus 3 equals distributing 7x plus 14. And then get y alone. Y equals 7x plus 17. So that would be part B. Part A is that slope intercept form. Part B is when you get y alone. And there's only one of those on the quiz. All right. Any other questions? If not, I have to apologize. I need to remember where we left off. And we had left off with that idea of finding the equation of the line using the point slope formula. Any other questions on the homework? So then we left off with that point slope formula. Which was y minus the y value is equal to the slope times x minus the x value. And we had looked at finding the equation of the lines when we were given a point and a slope. We looked at finding the equation of a horizontal line, which we said was just y equals the y value of the point. We had said that the equation of a vertical line is just x equals the x value of the point. And we had said that if we have 2 points and we want the line through 2 points, to find the line, we're going to first find the slope. And this was the last thing that we did after we found the slope. We used the point slope formula with either line. And does everybody remember doing all of that? Does anybody have a question on any of that? If not, today we're going to add a little bit more to our knowledge of lines. And the first thing that we're going to do is we're going to integrate what we had talked about earlier with respect to intercepts. And we had said that the intercepts are where a graph crosses the axes. And we had said that the x-intercept, because it's a point on the x-axis, will have an x coordinate and the y value would be 0. And the y-intercept, we had said because it's on the y-axis, the x value is, I got my A's and B's mixed up. I apologize. The x-intercept is usually thought of as A0. The y-intercept is usually thought of 0B. So we're going to do something a little bit theoretical before we look at more practical hands-on example. And what we're going to do is we're going to say, what happens if we use the y-intercept, which is that point 0B, in the point slope formula? Well, again, the point slope formula is y minus the y value of my point is equal to the slope times x minus the x value. Well, if I'm using this intercept, the x value is 0 and the y value is whatever number b is. And so this becomes y minus b is equal to m times x minus 0. And if I take that equation and try to simplify it, and if I go through and solve for y, I get first y minus b is equal to, well, x minus 0 is just x. So that becomes mx. And then if I'm solving for y, I'll add b to both sides, and I'll get y equals mx plus b. And this we referred to when we solved for y before as being function form because it's solved for y. But this also has another name. It's called the slope intercept form of a linear equation. And so in my equation, if it's solved for y, it always turns out that m, the x coefficient, is the slope, and b, the constant term, is the y-intercept. And so that's why it's called that slope-intercept form. And what's cool is it gives us a second method for graphing a line. And that's by using the slope-intercept. So because I don't want this page to run on too much, let's look at an example. I'd like to turn the page before I look at an example. Does everybody have this all down, or do you need for me to wait a minute? Everybody ready?
Yeah.
So, whoop. Let's look at an example of graphing a line with the slope intercept. And as we go through how to do it, let's look at an example. Let's sketch the graph of the equation, let's say x plus 2y minus 6 equals 0. If I'm going to graph this using the slope intercept method, I first need to get it in slope intercept form, which means the first thing that I want to do is solve for y. So in this equation, to solve for y, I'm going to subtract 2y from both sides, which gives me x minus 6 equals negative 2y. And then to get y all alone, I'm going to divide everything by negative 2. When I do that, I need to remember that this x coefficient is 1. And so when I simplify what's on the left, I can think of that as 1 over negative 2, or negative 1/2 x. Negative 6 divided by negative 2 is positive 3. And on the right, I've got y. Or y equals negative 1/2 x plus 3. Now, what I want to do is I want to, from there, identify the y-intercept and the slope. Well, some people like to compare it to that general equation, y equals mx plus b. Or we can just remember that m, the slope, will always be the x coefficient. I once heard somebody described it as being married to the x. And so the slope is negative 1/2. And b is the plain old number, that constant term. Or 3, and that's my y-intercept. Now, we're going to begin at B on the y-axis. And what you have to remember is we begin on the y-axis. So, oh dear. Give me a second. I just remembered that I learned a new trick yesterday from somebody in class. I can use these line tools to make my axes look prettier. And so I've got my x-axis, I've got my y-axis. I'm going to try to scale them somewhat evenly. And so B is where I begin on the y-axis. And so B is 3. In my example. And then I move according to the slope. And we said that the slope was the rise over the run. And so here, my slope is -1/2. I always assign the sign, positive or negative, to the numerator. And so -1/2, negative means I'm going to go down 1, and then over 2. And when I move over, because I'm always thinking of that denominator as being positive, it means that I'm moving to the right. So I'm going to go down 1, right 2, down 1, right 2. Usually do it a couple times. And I should be able to put a straight line through those points. And I've got it. And so with this way of graphing a line, what you need to do is solve for y, begin at the constant, and move according to that slope. Not too bad. Let's have you folks try one. Let's sketch 2x minus 3y plus 12 equals 0 using the slope intercept. Method. And so I'm going to ask you folks to try this. I am going to shut up and ask you to please solve for y. Identify M and B, and try to apply that to the graph. How are you folks doing? The first part, solving for y. Did everybody get y equals 2/3 x plus 4?
Yes.
So did everybody recognize that the slope was the x coefficient 2/3 and the intercept is 4? So we'll go to 4. It's always, you've got to remember, it's always the y-intercept. We always begin on the y line. And the slope is always the rise over the run. Because it's positive, I'm going rising up to over 3, up to over 3. And so hopefully, although you guys are probably better at drawing than I am, hopefully your line looks something like this. Any questions on graphing using the slope intercept method? If not, another type of problem that you might find is something that asks you to write the equation of a line with a given slope, let's say slope -4 and y-intercept, let's say 10. Well, if I'm given the slope, I know m. And if I'm given the y-intercept, I know b. And so I can just go right to my y equals mx plus b and substitute. And so hopefully those questions are straightforward enough, not too difficult. There is a third way of graphing a line that, depending on the format that your equation is in, can be easier than the slope intercept. And that's to graph a line using just the intercepts. And so let's look at that equation we just graphed, 2x minus 3y plus 12 equals 0. And let's graph this one using the intercepts. First, I'm going to I'll find my x-intercept by substituting y equals 0. So that would give me 2x minus 3 times 0 plus 12 is 0. Or 2x plus 12 is 0. 2x would be -12, so x is -6. Then I'm going to find my y-intercept by substituting x equals 0. And so that gives me 2 times x is 0 minus 3y plus 12 is 0. Well, 2 times 0 is 0. So that just gives me -3y plus 12 is 0. If I subtract 12, -3y is -12. And so dividing by 3y is 4. And then I'm going to plot my intercepts to graph the line. I cross my y-axis at 4. I cross my x-axis at -6. And there's my line. So let's have you folks try one. Let's ask you to find the intercepts and sketch the line. And let's say this time our equation is 5x minus 2y equals 20. So again, I want the x-intercept, the y-intercept, and then I want a graph. And I'm going to be quiet and let you folks work on this for a minute, and then we'll go over. Did everybody get an x-intercept of 4, a y-intercept of -10? So we'll cross the y-axis at -10, the x-axis of 4, and there's our line.
Yep.
Any questions? If not, we're going to move out of section 2.3 and into section 2.4. And section 2.4 deals with more about slope. And when I talk more about slope, in this section, we mostly concern ourselves with 2 types of line relations. Woo! My hand hit something there. Two types of line relations. The first are parallel lines. And again, I'm talking to a room full of intelligent college students. I'm rather sure this isn't the first math class you've taken in your lives. Can anybody remember what it means for two lines to be parallel?
To be offset from each other.
Okay, can you add detail to that idea?
Like they're the same two lines, but there's a distance between them.
Okay, so there's an equal distance between them. Usually folks tell me that they never cross. When I think of that word parallel, I think of the L's in the word parallel. The L's in the word parallel look like parallel lines. We're going to alter this definition a tiny bit. We're going to say that parallel lines are lines with no points in common, which gives me that idea of lines like this, or like my L's, lines that will never cross, because I like that phraseology, one's offset the other. It's like I just slid one down. Or there's another part of the definition. We also look at them as lines with all points in common. And I know sometimes people have a little bit more of a problem wrapping their minds around that. I could have one line, we'll look at this red line, and then we can have another line that's right on top of it. And this idea that they could have all points in common allows me to say that any line is parallel to itself. So they either never cross or they're the same lines. Well, if two lines are parallel, either never crossing or always being on top of each other, can't we say that they go in the same direction or they have the same slant? And in order to go in the same direction, to have the same slant, well, the measure of slant is slope. And so we'll say that two lines are parallel if they have equal slopes. And we'll find two types of equations, two types of questions, pardon me, that deal with this. But when I see that word parallel, I immediately think about slope. One type of question would ask something like, are the given lines parallel? And we might have a couple of linear equations. Y equals 3x plus 4. And let's have our other one be 12x minus 6y equals 18. And in order to answer this question, are the lines parallel? When I see that word parallel, I think slope. So I'm going to start by finding the slope of each. And so the first line, because it's already solved for y, I can think of it as being in that y equals mx plus b form. So I can say m, the x coefficient, is 3. This other line, I need to do a little bit more work. This other line, we're going to have to start by solving for y. So I'll subtract that 12x from both sides. Be careful. Remember that the 12x and the 18 are not like terms. So I'll have minus 12x plus 18. Then I'll divide both sides by -6. And I get y equals 2x minus 3. And so what's the slope of this line?
Two.
2. And so now I'm going to compare the slopes. Well, they're not the same. So here my answer would be that the lines are not parallel because they have different slopes. The other type of question that we might see is we might be asked to write the equation of a line parallel to a given line. So next example, let's find the equation of a line parallel to a given line through a given point. And so let's try to find a line parallel to 2x minus 3y minus 7 equals 0 through the point. Let's say our point is -2, 3. And I want it two ways. First, I want it in slope-intercept form. And then I want it in general form. And once we get it in general form, I want to compare it to the original line and show you guys a shortcut. To find it in slope-intercept form, the first thing that I need to do is find the slope. And so if I have 2x minus 3y minus 7 equals 0, to find the slope, remember it means we want to solve for y. So I'll add my 3y to both sides. Giving me 2x minus 7 equals 3y. And then to get y all alone, I'll divide out the 3. And so that'll give me y equals 2/3 x minus 7/3. And so my slope equals 2/3. Now that I know my slope, I'm going to use the point slope formula. And so again, that's y minus the y value is equal to the slope times x minus the x value of the point. And our point here is -2, 3. So that gives me y minus 3 equals my slope is 2/3 times x minus 2. For slope intercept form, we're going to solve that for y. Y minus 3 equals 2/3 x minus 4/3. And then when I add 3 to both sides, I have to remember that 3 is 9/3. And so that gives me y equals 2/3 x plus 5/3. Now, let's see, I think I want to move.
Where did the 5/3 come from?
Give me a second. The 5/3 came from remembering that in order to add to a fraction, I need a common denominator. And 3/1, if I multiply by 3/3, gives me 9/3. I've got my common denominator, I'll keep it. -4 plus 9 is 5. Better?
I just need a second to get that down.
Okay. Does it make sense though? Ready?
I'm just, I don't know. So that would become 1/3.
What would become 1/3?
Could you put 3/1 times 3/3?
3 times 3 is 9. 1 times 3 is 3. So 3/1 is equal to 9/3.
Oh, and that's where you added them. Okay, I get it.
Okay,
Thank you.
you're welcome. Now for general form, we want to make one side 0. And so if I subtract y from both sides, I get 0 equals 2/3 x minus y plus 5/3. And general form, you can usually stop there, but I'd like to clear the fractions by multiplying by the least common denominator. And so over there where I have 0 equals 2/3 x minus y plus 5/3, the only denominator I see is 3. So I'm going to multiply both sides by 3. And distributing here, I get 0 equals 2x minus 3y plus 5. Now, the reason I wanted it in general form is I want to compare that parallel line to, I'm going to shrink things up just a little bit, my original line. And so the original was 2x minus 3y minus 7 equals 0. And the parallel is 2x minus 3y plus 5 equals 0. Does anybody notice anything similar about those two equations?
One starts up higher on the y-intercept.
Beautiful, beautiful. The y-intercepts are different. I'm looking at more like physically, if I compare those two equations, does anybody notice that the x coefficients and the y coefficients are the same? All that's different is the constant. And that makes sense because when I had that original line, when I tried to find the slope, when I solved for y, didn't the slope involve the x and y coefficients? And so that gives me another way of finding a parallel line. But be careful, this method only works if you're in general form. Method 2 says that a line parallel to ax plus by plus c equals 0 through a given point, x1, y1, is given by ax plus by, because in order to be parallel, the x and y coefficients have to be the same, equals. And what's really cool is that new constant is determined by my point. And that new constant has to satisfy this equation when I go through that point. So the new constant is equal to a times the x value of the point plus b times the y value of the point. So if we look at that same problem, we wanted a line parallel to 2x minus 3y minus 7 equals 0 through, what was our point? Our point was -2, 3. Well, a is 2, b is -3. So I'll start 2x minus 3y equals, and on the other side, I want to make sure that my point works. So that would be 2 times the x value, -2, plus 3 times the y value, 3. So that gives me 2x minus 3y equals 5. And I get that 2x minus 3y minus 5 equals 0. Oh, wait a minute. I'm off by a sign. Where did I get off by a sign? Oh. Oh, Lord. Guys yell at me.
I was
Yeah.
wondering if we had to follow that sign.
minus 3y. Yeah, it was a typo. And so that gives me, this still is off. Where is the other number error? Oh, guys, the other number error was up here. I substituted in +2 instead of -2, right? You guys didn't catch that sign error. Minus a minus, that should be plus, which means that this should be plus, which means that this should be plus, which means that this should be 13/3, which means that this 5 should be 13, this 5 should be 13, this 5 should be 13, and this 5 should be 13, and this 5 should be 13, and this gives me -13, which makes it 13. I apologize. I wish I could say that I know that would be the last sign error I may ever make, but I don't know if that's the case. And because of that sign error, I need to apologize, which is supposed to be a nifty shortcut to get that equation. Turned out to be a pain in the ass because I made a careless mistake or two. I'm very sorry. But can you guys sort of wrap your minds around this shortcut? You don't need to use it, but if you're just looking for that equation in general form, it's the quickest way to get there. I do believe when you do these questions in my labs, at some point in time, they break them down into baby steps and ask you for the slope of the line and encourage you to use the point slope form. But isn't that sort of a neat way of getting to that same result? After parallel lines, the next thing that we look at are perpendicular lines. And can anybody remember what it means for two lines to be perpendicular?
Lined up.
What do you mean by lined up?
I kind of want to take my answer back now. They're like, next to each other, going in the same direction.
Uh-oh. Uh-oh. Same direction are those parallel lines. Perpendicular lines are that other P word. They make right angles.
Ah,
The symbol for perpendicular kind of looks like that upside down T because you've got those right angles there. And when we look at perpendicular lines, if we're looking in coordinate geometry, we have to break it down into two cases. The first case is really obvious. The first case says that if I have a horizontal line, a perpendicular line will be vertical. So first case says that a horizontal line and again, remember a horizontal line has 0 slope. The slope is 0. Is perpendicular to a vertical line. And remember, a vertical line has slope undefined. The slope does not exist. And so one way of telling if two lines are perpendicular or not, is if you look at the slope. If one has a slope of 0 and the other has slope that's undefined, then they will be perpendicular. The second case deals with slant lines. And to look at that relationship with slant lines, I want to draw a few. I'm going to draw one where my first line is really steep and it's going uphill. Would the perpendicular line be not very steep at all and going downhill? Second one, my first line is going to go uphill and be not quite as steep. And the second line is still going to go downhill, but isn't it steeper? Third one, my first line is going to go uphill, but not be very steep at all. And to be perpendicular, wouldn't the second line go downhill and have to be pretty steep? And as I look at all three of those, do you notice that with those pairs of perpendicular lines, one has a positive slope, and the other slope is negative? And as I compare them, do you notice that as one of the lines gets steeper, the other line gets less steep? And that idea of as one increases, the other decreases, as one gets steeper, the other gets less steep, means that they behave in opposite ways. And in order for them to behave in opposite ways, it tells me that the slopes act inversely or they're reciprocals. But they're reciprocals with opposite signs. So we say that the slopes are negative reciprocals. One's positive, the other's negative. And to say they're reciprocals, if one is A over B, I'd flip the other and get B over A. A long time ago, I learned one way of verifying that two numbers are negative reciprocals is to show that the product of the slopes is -1. They have to multiply to -1. And I just looked at the time and realized that we don't have enough time to go through the next couple of examples. So I feel bad leaving you hanging in the middle of a problem idea, but Would it hurt anybody's feelings if we stopped here?
No.
We okay? We'll pick up from there. Please remember over the weekend, everybody remember, if you came late, there is a quiz in my labs that you need to do and submit pictures of your work in Blackboard. A few questions where you have to find the slope of a line through a couple points, and one where you have to use the point slope equation to find formula to find the equation of a line. Azim, I believe I got that you came in. Taylor, I believe I got that you came in. Is there anybody else who came in late that needs me to make note of?